Hello, and welcome to AWS Review, a weekly look at what's happening at AWS and how it may change how you do business. I am your host, Michael Krause. I am the Chief Technology Officer at Charter Solutions, where we help organizations change and innovate quickly by accelerating their acquisition and use of data.
And I'm your co-host, John Affolter. I'm the lead technical architect and on the AWS specialist team at Salesforce, where I work with potential customers, helping them envision the possibilities that AWS and Salesforce enables.
Excellent. Well, welcome back, John. It's been a couple of weeks, but we are back at it again. Hopefully the summer's going well for you.
Yeah, no, I feel like we are in the thick of it here, and I also feel like the Boys of Summer song is going to start playing on the radio as we start battening down the hatches for the long, cold, dark winter. But anyways, other than that, it's great.
Yeah. It's summer's been going way too fast. I had annual weekend away this last weekend with a bunch of my friends, and we spend all winter and part of the summer looking forward to it, and then all of a sudden it's over, and It just goes way too fast.
Yeah, no, I definitely I love August, but yeah, it's just one of those months that's pretty bittersweet. But anyways, I'm excited for the fall. I do love the fall. It's just that season afterwards, not so much. But anyways,
I think that's why my son moved down south away from Minnesota, is to get away from.
Yeah, that'll happen. I made a mistake of moving back, but I mean, Arizona. I lived in Arizona, and that was too hot for me. But I don't know. It looks pretty good in January. But anyways, before we move on to the topic of the day, which is the data science process on AWS, let's take a look over what's been happening at AWS over the last couple of weeks. And obviously, quite a bit happens over a couple of weeks. So we'll kind of run through some of these and describe a few of them, but we might just kind of mention a couple of them. So the first one is the Amazon Chime SDK now announces Elastic Channels. So it's messaging that supports large scale chat experiences. So up to 1 million users at a time. This could be things like watch parties or political events or live entertainment. This is definitely a update that brings Chime into the forefront on a lot of things, where I've seen even AWS and other companies use other services for things like this in the past. So, I think this is a big update for them, just for kind of just branding as well for Chime.
That's very cool. Another update regarding AWS Deep Racer, which is something we talked about in our last episode. AWS Deep Racer Student now offers community races and new Intel learning content with a look under the hood of the Deep Racer vehicle. So AWS Deep Racer Student is a global autonomous racing league for students, offering free educational material and resources to get their hands on with machine learning, powering the 1/18th scale Deep Racer car. And now available, they have these student community races and additional learning content diving into OpenVINO Toolkit, which is provided by Intel. And what's interesting about this is educators and event organizers can now create their own private virtual races and invite students to compete through the AWS Deep Racer console. They can select their own track, race data, a race date, race time, and invite students to participate through a unique link for the event. And students can participate in the community through a AWS Deep Racer Student, where they will have monthly access to 10 hours of model training and 5 gigabytes of storage to train their models at no cost.
That's anything that improves the democratization of machine learning, I think is fun. The Deep Racer League, I know that even a lot of companies, I think UHG and Optum, they had their own Deep Racer League, I think, at one point. So that's pretty cool. Amazon Personalize allows now rules-based promotion. So you can basically specify different rules that are going to align with your certain business goals. So, for example, if e-commerce customers can use this feature to fill 20% of recommendations with the items marked as on sale, that's something that they can start to set rules towards. So really starting to kind of leverage the recommendations for what you actually kind of want to sell. So pretty interesting. And then also another update from Personalize is that you can now do incremental bulk load. So being able to really simplify the data ingestion process and just do small imports at a time, and doing all of this with no ML experience needed. So I really love the packaged AWS AI solutions. I think they're really gonna help augment a lot of other types of systems in the future. So.
Well, it provides a way for people to start leveraging AI ML type stuff without having to be experts at building and training models.
Yep.
All right, so let's do a few kind of rapid fire updates here. First one, AWS RDS Custom for Oracle now supports scale compute. So you can now scale your Amazon RDS Custom for Oracle instances up or down.
Yeah, Amazon Event Bridge now supports receiving events from GitHub, Stripe, Twilio, and also all using webhooks. So that should be pretty interesting.
Yeah, another way to get data into the system. In addition to that, AWS AppFlow now supports data transfers from SAP applications to AWS services using SAP operational data provisioning. So another integration that automates data movement.
Yeah, and then also supports Zendesk Chat and Zendesk Sell as sources as well. So
yeah, more and more. Amazon EKS and Amazon EKS distro now support Kubernetes 1.3 or 1.23.
Cool. Amazon EBS now adds the ability to take crash consistent snapshots of a subset of EBS volumes attached to an Amazon EC2 instance. So
excellent. You want to take the next one as well, since that's a little
more. Yeah, sure. So Amazon SageMaker Canvas expands its capabilities to better prepare and analyze data for machine learning. And I'm sure we're going to get into this later, but Amazon Canvas is SageMaker's low code, low code machine learning, I guess, interface that you can have a business analyst that can use drag and drop functionality to be able to manipulate data, impute it, change values, really formulate it to be ready for a data model, and then also run the model and run through all the different hyperparameters all without any code. So pretty cool.
Excellent. An update to AWS Glue. They now support a flex execution option. So this is really cool for people who are doing a lot of development work, leveraging Glue for ETL and such. AWS Glue now supports a new execution option that allows customers to reduce the costs of their pre-production test and non-urgent data integration workloads by up to 34%. So with Flex, your jobs can now run on spare capacity in AWS. So it's I'd say it's akin to the concept of spot instances in EC2. So
yeah, that's what
we slower if spare capacity is low, but as long as you can deal with that, you can save some money.
So that'd be flexecution then, I guess.
Yes, exactly.
So SageMaker Pipelines now supports sharing of pipeline entities across accounts. So I think this is a really huge update, especially if you're working on building a very large machine learning ops platform, or you maybe have different business units with their own data scientists. We'll get into it later, but really, I think that's the main power of AWS is the ability for you to take something from an idea and get it into production pretty quickly and be able to share that. And I guess I'll just talk about the next one, which SageMaker automatic model tuning now supports alternate SageMaker training instances for more robust training. So just giving different options at different times. really filling in the blanks with different types of workloads that you might have, really to cut down, either optimize or save money. So
Excellent. Lots of changes that are coming out. So again, this is kind of typical, and it's been fun to watch because we've had some weeks where it's like, well, we've got one or two things, and then we have other weeks where it's just exploding. It'll be interesting to see what happens around reInvent. We may not be able to even have topics to discuss because we're spending all our time talking about the new stuff that's being announced.
Yeah, no, I think it's a good problem to have, I guess, and
Yep.
but it's kind of a double-edged sword, right? And we've talked about this before. Is as Amazon adds all of these capabilities and having each technology be able to do multiple things, it's tough to have really what is the best way to do it. But
Right.
I think that starts to formulate over time, and I think that we're really at an exciting point with integrations and the ability for everything to be low code and serverless, and really kind of leverage what AWS's vision was from the beginning. So
Agreed. All right. Well, let's dive into our topic of the day. And today we're going to be taking a look at the data science process on AWS. So this is kind of another um, entry into our series on data science, ML, AI on AWS. And John, I think today we're going to be reversing the roles a little bit, and I'm going to be asking you more questions than I'm answering.
yeah.
So why don't I start out? And let's start about simple question. Why do we need a process? Let's just start with something really simple like that.
Well, I think a quick and easy answer is that if there's not a process, what you're going to have happen is that there is a certain very large company in the past that hired 1,000 PhDs to come and do a bunch of data science and a bunch of cool, types of use cases to try and develop products. And after 2 years, 0 products were developed. So, I mean, this kind of leaks into product development too, but we really need a process to understand what the problem is we're trying to solve and make sure that the way that we're gathering the data is in a way that we're answering the right questions in the right way. So, and not just answering the questions, but how do we take that question and answer it in other places too, and really truly get back to the experiment or the science piece of it and being able to replicate results. And I think that's something that, when you get really deep into deep learning and into these black boxes, it's tough to be able to replicate things over time and improve it over time if you don't have a solid process in place.
Excellent. So, since we're talking about the data service process or data science process on AWS as our topic, is the data science process that we're talking about AWS specific, or is there a generic process that people should follow and then leverage AWS to apply it?
So you have different acronyms down, but I'll go with the OSEMN. So really, it's always being able to obtain the data. So how are we getting the data into our system, and not just into the system where we can use it, but also how are we, and this is maybe later too, but how are we obtaining data in a way that we can have this in a pipeline to where we can continuously update it, if it's going to be a model that we're going to use continuously, or one that's not going to one that's going to have to be updated often. So the others are, the next one would be when you scrub the data, or kind of formulate it, or taking a look at what is the issues, what are the missing data pieces. And this is also a little bit with discovery too, which is also in here. It's the E part. So, and we'll get you a link for all this, and that's exploring the data. So a lot of times you actually are exploring the data as you're scrubbing it, because you're looking at what are where's the missing data? Where do I need to impute values or change them around? And also by exploring that data as well, you can understand of what data you even want to even utilize at all. And you might be able to cut down in the amount of scrubbing of data that you need to use, or depending on how the data is distributed, that might be something to where you have to, maybe even do smote and have to add different pieces of data as well, or fake data. And then there's a bunch of different ways that you can impute the data and fill missing pieces of data as well that might be different depending on how your data is distributed or what the problem is that you're trying to solve. So I kind of group two in the S piece, which is scrubbing the data, and then exploring the data. Exploring data is really, it's a huge missing piece in a data scientist that just comes up and starts looking at perfect data sets on Kaggle, is that there's such a long process in just trying to understand how we're going to solve a problem. And obviously through trial and error over years, there's general ways to do certain types of use cases, but that can totally change depending on your business needs. And also, is the juice worth the squeeze on some of these things? Because Michael, you taught me real early that, yeah, you could solve it with deep learning, but likely you can most likely do it with some linear regression or logistic regression, and it's going to work within 1% and save you about 90% in cost. So there's a lot of that happens in the exploration of data that never used to happen in the data science process. It was just like, let's throw some money at it. It's really cool. And it's almost like the idea that you're doing quote unquote AI is almost worth the money and compute that it's almost like a marketing cost at that point. So I think that's a big part of the process that is left out in the past. And I'm gonna talk about the other parts, and then we'll maybe kind of circle back through and talk about what tools you would use for each part of this process. So
sounds good. I'm going to interrupt you for a quick second, if you don't mind. We'll pick back up. We actually have a question from one of the viewers. And nice. I think this is a good question because I think we can weave it into our conversation here. So Tadashi is asking about interest in data science and would like to know more about how somebody new into the space can work in data science. What do they need to learn? I'm guessing. What do you need to understand about it? How do you start getting involved? So maybe as we kind of go through this, we can weave a little bit of guidance for people who may be new or considering getting into data science as part of this.
Yeah, no, absolutely. I appreciate the question. And the first question, so this is a exciting moment for us.
Moment, yes. Thank you.
So yeah, I think obviously my suggestion when anybody goes to start data science, start with the least fun stuff first. Because it's really easy to dive down deep and reproduce a lot of notebooks and stuff like that and get a cool score and feel real good about it. And it's not to discourage people from data science. It's more to keep them from being discouraged in the future when things start getting a little crazy. So, I guess
I'll toss in another plug here. I think it was the last episode or the one before. So check out episode 13 and 14. We talk about learning resources that are available on Amazon around how to learn about data science, how to learn about AI, ML. So things like Deep Racer, Deep Lens, Deep Composer, various training classes and other things that are available for free. So definitely, if you've missed those episodes, go back and look at those. We provide a whole bunch of different ideas as well.
Yeah, and then AWS has AWS workshops as well, and that is a really great resource. Obviously, YouTube. I'll provide a bunch of links afterwards that you can take a look at. But just generally, my suggestion is one, learn the statistics behind it and understand why you're doing certain things. And that's a big part. A lot of that happens in the exploration part too, is that you can really understand how to create and how to engineer great features if you truly understand the statistics. And feature engineering is really what separates, a citizen data scientist from an expert data scientist, and really understanding the statistics and how to do that. I used to think, you have to be very, very heavy in data engineering, which that's starting to go away thanks to AWS. But just really understanding some basic manipulation of data, basically, essentially what AWS is handling for you in things like Canvas, things like Data Wrangler, where you're changing, you're moving the data around, you're moving columns, maybe you're combining columns and creating one feature, maybe you're taking aspects and creating another feature, or just cleaning the data in general. They used to say that used to take 80% of the time. Well,
Right.
that's starting to get reversed now thanks to AWS. But I would say the big thing about that, as long as we're on the exploring data, the big thing about that is understanding statistics. So what to use when, and how your data is distributed, and how to do that feature engineering. So I guess I might as well just jump into some of those tools. I mean,
well, let's
yeah. Or we can just jump to model,
and then we can walk through it again and talk about how you can use some of the different tooling to execute those different steps.
Great. See, we're switching places now, so I'm like fish out of water over here. So modeling the data is, there's a couple of pieces of that. There's one is modeling, putting the data into a way that can be consumed by that specific model. That's one, and that's part of the exploration that really kind of segues right into the modeling of the data. And then two, you have to process that data. You have to run the actual compute on it, which that used to be a whole another set of skill sets and a whole different team sometimes, depending on it. Or you just had to be a one-stop shop data scientist that's also a data engineer and also a software engineer. So now the modeling is really getting it, training the data on the other on that training set, and figuring out what are the levers essentially within those features that you're choosing that are the DNA for the answer that you're looking for, depending on the next person or the next set of data that you're looking to run the inference on. And the inference is basically taking that little playbook and running it against different data. So there's a lot of different ways that can be done in different parts, and that will kind of run back through afterwards. But then once you get a model, you have to interpret it. So that is also another thing that used to be very impossible, but now there's different things built into SageMaker, and there's different types of things like SHAP analysis that can break down features and really show you what is influencing your model. And interpreting that result is really another place where there's a fork in the road between a good data scientist and a great data scientist, is the ability to tie it back to the business use case and be able to explain it in layman's terms, and showing it on the graph, explaining the confusion matrix, explaining why you set the model at a certain sensitivity. Because with some types of use cases, you might be better off having a false positive, something like this is maybe a bad example, but maybe testing for diseases or anything, it might be better to have a false positive because at least you're going to take a closer look. Whereas if it's for a pre-employment drug test, maybe it's not good that somebody has a false positive and it keeps them out of employment. So different ways of explaining why you send sensitivity to the model, or even let's take another one like churn, right? So you'd rather predict somebody would churn and put in a little, send them an email or do something than predict that they weren't going to churn and lose that customer. So that all comes into the interpretation of results. And then there's also the post-model development. So once you have that model, you still need to deploy it in production. And this is where even the largest companies fall flat. And there's so many aspects to it. And AWS really simplifies that with all the different tools that we'll talk about. But being able to deploy that at scale is something that was, until very recently, a very rare thing that needed a very large team of people to do. And then once you get that model deployed, there needs to be continuous feedback loops and continuous improvement on that model. So really getting that model into a model registry, getting it into an experiment zone to where you can test different updates on the data, and also you can track it over time. And then more importantly, then you can start to do uplift modeling on all the things that the model is doing. So really tracking what are the downstream effects of that this model is having, and what is the attribution to the predictions that it's making. So
yeah, it's been interesting. I've seen a lot of companies who have spent a fair amount of resources in model development. How do we build these models? How do we train these models? All of this stuff, and then they find themselves kind of bottlenecked in. Okay, well, this is great, but now I want to actually run this in production. I want to run it in real time as things are coming in, and provide feedback to my my employees and how they interact with the customers and things like that. And so there is a balance that needs to be had here. If you put all your energy into building the models, but no energy in deploying them and applying them in a scalable way, you still haven't received any value from your models.
Yeah, but you spent a whole lot of money. That's for sure. And I tell you what, a data scientist is a lot more expensive than your regular BA or whatnot. So that's what I think is really amazing about what AWS is doing, is because I don't think there really is going to be that much of a shortage or need of data scientists per se, but maybe more people are going to be data scientists, and that, in a way, the citizen data scientist is coming. So I really think that then that allows those real deep data scientists that are really focused on the model and the math piece, then they can really go deeper on that stuff, and have folks that really like kind of a little bit of both sides of that be able to really start implement this at scale and see what this really does in the real world. And that I think is a pretty, we're at a pretty cool point in time right now. It can be scary, but it's also pretty fun. So I guess we'll circle back here. Within the obtained data, obviously there's a lot of that could be a whole different show, and I think we did one on ingesting data. But
I think we did a fair amount of conversation on tooling that's available in AWS in a few different shows, right? So we've talked about AppFlow, we've talked about Event Bridge, we've talked about the AWS Transfer family, we've talked about the Snow family for moving data in, we've talked about the data marketplace. So I think we've touched on the obtained data in a number of other shows. Is there anything in obtaining data that you would add from an AWS capability that we may not have talked about before?
I think that we mentioned briefly just around SageMaker pipelines and what that looks like. But I think in the terms of data science, I think being able to leverage SageMaker pipelines and also some of the other MLOps tools and the MLOps capabilities, because that might be a later stage in the data science process as we're talking about it, but it's also the beginning stage of the next data science process.
Right.
And the ability for you to take your model, get it into a pipeline that's also connected to other, connected to a model registry to where you're tracking your model and you can run experiments on it. And, I have article in here that is from a guy, I think he's from Google, but he says that A/B testing is dead. And there's just so many factors that come into the A/B testing that it's hard to really track the true attribution of it. Well, if you're using model registries and you're really having a full robust machine learning platform, you can start to at least try to move away towards that and really try to move towards a situation to where you can understand your attribution a lot more. And Michael, I know I've asked you about the problem of attribution in the past, and it's a tough nut to crack. And I think that if we can leverage things like SageMaker pipelines and the model registry, that helps to bring some clarity on things that would usually be stuck in somebody's notebook somewhere, or stuck, or really in somebody's head, or you wouldn't be able to access that information in any way. So if I would say one thing on obtaining data, that'd be the one thing is you re-obtaining it from the system, essentially.
I think, your attribution comment's interesting and important because oftentimes people view data science, especially data science as it relates to machine learning, AI type things, as a separate thing. Over here on the side, we're going to do this, right? Mm-hmm. But when you start looking at obtaining your data and some of the other things we're going to talk about, scrubbing and exploring and attribution and all of that stuff, to really be successful at that, the company needs to have a holistic data strategy that covers all of these things, right? Mm-hmm. And data science is a key part of that strategy, in addition to feeding your applications and doing visual analysis and other stuff. So being able to say, yeah, I need this data, but I need the attribution. I need to integrate with other sources and connect that up so I can get other attribution, so I can enrich that data in other ways, is a big part of being successful in my mind, beyond just the traditional data science pieces of it.
Well, yeah, it's like, is this data really representation of what's going on and what's happening? And the more places you can get data from and be able to essentially create your own little imputation strategy, just in different ways, right? You're filling in the blanks for other pieces of things that you can't see. So I think that's kind of the same deal.
One of my favorite stories about, properly scrubbing and understanding your data was back in, I can't remember which war. It was one of the world wars. Bombers were coming back and they were riddled with bullet holes.
Oh yeah, I know that. Yeah, this is a good one.
They were doing an analysis to determine where the majority of the bullet holes were, so that with the intent of being able to put more armor, to basically put better protection where the bullet holes are. And they found that there were a number of spots where there were lots of bullet holes, and they found a number of spots where there were like almost no bullet holes. And somebody raised their hand and said, have we considered that the reason that these areas where there are no bullet holes could be that because the ones that have those bullet holes are the ones that got shot down?
Yeah.
They flipped it. They actually started armoring the areas where there were no bullet holes.
Yeah.
So it is important to not only obtain and scrub and explore the data, but to do all of that with a mind that has a good statistical framework and foundation behind it. So you understand the implications of data that's present, data that's not present, data that's skewed versus not skewed. All these things are very important and can lead you to false predictions, false positives, false negatives, if you don't understand that.
Yeah, I mean, you can. Yeah, if you don't really understand the math, then just there's even little things as you're doing your hyperparameter tuning. So again, for those listening that want to learn, I would really try to understand the math first, so then you can really understand the hyperparameter tuning and what are the levers that you're pulling up and down. And the more you can understand that, then you start to become intuitive on what you're seeing on the graph, and that's how you can really be able to understand the loss function. So basically, what is the how are we varying from the the point that we had chosen before, and what is the change that we're going to do, and how big is that? Because you don't want to end up with certain things like getting stuck in a local minima or just different mathematical things that if you don't understand what's going on with the hyperparameters or how you're manipulating the model, then you won't understand why you keep ending up with these weird results. So
yeah, having a good basis in mathematics and statistics is very helpful in being able to be successful as a data scientist.
yeah, I mean, I think just in general too, and just understanding different levers and how things change with different stimuli, and that'll help you formulate a better business problem as well, because you'll start to really understand how things are moving through a system. So
Excellent. All right, so I'm going to pull us back to the process here because I think we've
yeah.
had a lot of good conversation here. But let's talk about scrubbing the data, and let's talk about what's available in AWS and how it can be applied from a scrubbing perspective.
Yeah, I mean, this is a doozy here too. It really depends on how you're setting up your pipeline, because you could end up doing a lot of that scrubbing, and you like to do this, Michael, and I've learned from that is really let's push it back towards the cost savings as much as we can. Let's get it back towards Redshift. Let's process it there. Let's do these. Let's do as much as we can there, and then we'll figure it out as we go, and try to really go from that prototyping. So really, as you're scrubbing data, this is another great thing that you do too, is when we explore it, let's take a look at it in Tableau and see what parts we need to scrub, and let's take a look at what are we getting into, because sometimes data scientists can be using such large pieces of data. So Tableau, QuickSight on AWS, but what are we looking at here? And then we can start to chop off and kind of at the same time formulate kind of business plans. It really depends if you're going in just trying to look for a problem or if you have a problem already. So also things like, there's also Glue, and then obviously Data Wrangler, SageMaker. But the more you can get that done earlier in the pipeline and not have your data scientists do it, I think the better.
So then is it fair to say there's probably like two categories of tools within AWS? The more generic data processing tools like Databrew, AWS Glue, even Athena, where you can manipulate the data, scrub it, filter it, create new data sets from that can be brought in, and then tooling that is more available as part of Amazon's kind of AI ML suite of tooling?
Yeah, I would say really it's where are you entering in from? I think that makes a difference too, and where are you spending a lot of your time? Because realistically, you can do the same thing with Glue as you can with Data Wrangler, as you can with Data Brew. It just depends who's working on it and what are they doing. Are they doing ad hoc? Are they doing something that's building towards a bigger system? Have you already done the prototyping and maybe you're moving back? So that's really how I'd kind of break it up is where are you at within your process too? Because if you're, just starting off in prototyping, you might want to just work and stay within all of like the autopilot, the SageMaker autopilot, stay within Data Wrangler, stay within these things that are really quick to move around. Just like if, back in the day where you could, use Tableau essentially to move stuff around, and then you'd go back and give it to your ETL team to handle on the back end. So that's how I view it. I think SageMaker it gives you a one-stop shop if you want to, because you can still access those other tools. And then through your data engineer,
Yeah, so that's a really good point, because I think the other thing to keep in mind is oftentimes when we're further forward in the process, our needs are more specific.
Mm-hmm.
And, if you take even a simple example like, oh, I've got this data set and I need to get the date formats normalized so that I can build a model with it, right? Well, the reality may be, yes, you do, but we also need to use that data set for a bunch of other reasons, and we need the dates normalized for that as well, right? So I like your pieces. You may play with it, but we also need to be cognizant of things that we need to push up or down back upstream in the process, so that that can be done ahead of time because it serves multiple purposes and not just one.
Yeah, it's almost, I really, and this is like the part of the process too, is that always gets missed is kind of that end part. It's like, okay, how do we deploy in the feedback loop? And that's always something where, it's like almost like a data science team can be like a bull in a china shop, really coming in and okay, maybe you have this really impactful model, but hey, maybe that's causing a lot of other issues on the feedback loop, or maybe the business isn't even accessing it. And it really becomes especially if you're in a large organization and have different pots of budget, cash, and all that, it can really make things kind of a nightmare. And I guess the whole purpose of doing data science is to try to improve an outcome, and that really hinders the ability to do that. So, scrubbing, there's a lot of places to do it. You got to figure out, you got to set that process,
Yeah, and I think an example some of the things you said just triggered a thought for me. An example of a need to push things upstream would be, think about training sets, right? So if as a data scientist you're building a model, you brought in data, you're developing a training set, and you manipulate a set of data so that you can use it as your training set, you're effectively creating your input definition for your model, right? Now we take that model, we roll it out into production, and guess what? The data that's coming in doesn't match that input definition, right? So now we've got another spot where we have to add another manipulation. But if we are, again, holistic about it, and we start figuring out how do we push that upstream, so now the data coming in for training and the data going in for actual execution in the operational version have the same structure. Now we're doing it once as opposed to multiple times and maintaining it in multiple places.
Yeah, and that's kind of like, one of the things with data exchange is that it handles a good amount of it, but still at the same time, it's not like you can just press, hey, here, I want this data set, and it's in this model and it spits out a thing. It's like there's still a lot of work that goes into it, but AWS is handling a good portion of that front end work, that where maybe your DBA or somebody else is doing it, at least for your domain, I guess, and where maybe they got some raw data sets to go in there. So kind of, Michael, the structured curated zones and really kind of having a little bit of freedom, but also some formatting. It's the canonical models. The more we can get the canonical, the better. So
let's move on to exploring and talk about some of the tools available in AWS for the exploring portion of the process.
Yeah, I mean, I think, we kind of hit on it before, is that you can take a quick site and you can explore the data. I think Athena is obviously a great tool to do that. Data Brew is going to be something to where an engineer or a business analyst, they can get in there and really understand what that data looks like, and then also do manipulation on it. And really what I liked about Data Brew as well when it first came out, and now it's in SageMaker and everything like that, it analyzed the data set for you, and it broke down the distribution, and it told you ahead of time what all the missing values were. And not just that, it also allowed you to quickly change it. That used to be, just that step alone used to be quite a bit of coding and quite a bit of moving around. And just being able to do that really quickly with that drag and drop low code functionality, it takes away a lot of work that needs to be done every other time anyways, and is not a differentiator at all. So
you don't really like having to create data frames in Python and do all kinds of stuff.
Yeah, and then move it from data frames to pandas to
rather just point at a data set and say, give me the stats.
And then it changes the data types on you and assumes data types, and that's machine learning gone wrong right there.
Yeah.
But
so In the conversation today, you've mentioned SageMaker Data Wrangler and SageMaker Canvas a couple of times, and I'm sure we're going to have some deeper dive episodes on both of those things going forward. But maybe for the audience, you could provide just a very short definition of each of those.
Yeah. So basically, Data Wrangler it allows you to really aggregate all the data and prepare it for machine learning and getting it into getting into a format to where your models can consume it really quickly. And then that can,
tool, or is it a programming based tool?
It's drag and drop functionality. I think there might be I might be able to here. I was trying to pull it up here.
Yeah, don't worry about that.
But yeah, it's just, it's like a flow builder essentially. So trying to think of it more of like an Informatica, I guess, than it would be just working with hardcore Spark or whatnot. But really being able to, drag and drop, see visually what's happening, see the steps in between. And then that can feed right into your SageMaker Autopilot. So SageMaker Autopilot, what that's doing is it's AutoML. So it'll take your inputs and it'll have a bunch of different types of models and then a bunch of different hyperparameters, which are basically different levers that change around what that model does. And it'll test through all those like right away. Like basically, again, something that used to take a lot of time, a lot of coding to be able to run and loop through different hyperparameters, and also all those hyperparameters, they might have different levels of compute needed as well. So, Amazon will help take care of that for an optimized way to train and test your models as well. So Data Wrangler feeds into the Autopilot. Autopilot can pick your model and choose. So Canvas is really a full, it's no code, but it also, I'm going to just pull this up so I don't say the wrong thing here. So it's basically helps you build those models as well on top of it. So you're not just getting it picked for you necessarily, which you can run AutoML stuff from it too, but it's helping you build the model with your own knowledge tied to it. And you can really analyze the different outputs that are coming from it to be able to move it on your own. And then you can really, with Canvas too, it breaks down, and I forget what they used to call it in SageMaker, but it's basically the explainability of the model. So something like a SHAP analysis where it'll break down and show you the impacts of the different features that are impacting that model. And actually,
prediction.
Yeah, why are we making this prediction? And somebody on my team had made a pretty cool demo off a AWS Jumpstart. So AWS has, and that's another good resource too, for those that are listening, is AWS Jumpstart. It's basically, for lack of a better term, it is a jumpstart to machine learning with a specific business case and a model tied to it, to where you can, it's almost like getting a CloudFormation script or a quick start, where it build the environment for you, and then you go and it'll walk you through the problem and show kind of, how to move it through. But the point being is that it gets you to a point to where you can, it'll break down what you are impacting on the thing. So if you have like a credit score and you want to understand, okay, what is impacting this credit score, you can also do little levers that say, all right, let's pull down the lever here. Let's lower the term of the loan. So, okay, lowering the term of the loan actually improves their impact of default. They're not going to default with a shorter term loan. So that's just one example of where you can start to take a look at the levers and move those around. and see how that's impacting your model, so then you can tie it back to a business problem. So
Right. Well, I'm going to try to be a little sensitive to time here and keep us moving.
yep.
So let's talk about modeling the data. We talked about exploring. Tell us a little bit about some of the tools and how you might use them from a modeling perspective.
Well, again, I think, again, Canvas is going to be something you can use, and then autopilot as well. And then I think when you're in your pipeline too, is there's different parts of modeling, right? It's getting it into your data set, or into your data set in a way that it can be consumed by whatever model that you're utilizing. And then also it's how are you tuning that model as well? So like I said, with autopilot, that runs through all that hyperparameter tuning. If not, then you're kind of looking at it. If you want to really go more prescriptive, then you can really kind of look at it in SageMaker Studio and just do different types of analysis on the data and trying out different features as well. And that can be done in the exploration piece of it as well, just to try to figure out what that looks like. But then you're going to have to put it in the model, and then that might not be the impact that you're expecting, or maybe just even how you're processing the data, and how many epochs are you running through, and there's a lot of different things that you can tune that will make sure that you're not either overfitting or underfitting your model. So an overfit would be, something to where in your testing set that, you're hitting you're hitting every single point on it, and you're making kind of a zigzag up the thing. And an underfit is where, you're too far off, you're not moving with the flow of, let's say that it's, moving up, left to right. It might be going up and down, and you might be zigzagging with an overfit, but, in an underfit, you're just having that nice straight line all the way up, and you're not kind of form fitting to anything at all. So those are two problems in data science that you run into, depending on how you're training your model and how you're setting your loss functions and your hyperparameters. So that's something that you need to take a look at.
Yeah, so you're flowing us into now interpreting the results as well.
Yeah, so right. That's the thing about the data science process is one begets the other. So if you don't have a good process, you're gonna fall flat at some point in the process. If just one little piece is not working well, then you can't do the other part well. So just modeling that data, there's, again, it's kind of the problem of AWS. There's a lot of different ways to do it or look at it, or you could do deep learning is going to be different than how you're preparing your model for a linear regression model sometimes. So there's a lot, maybe the amount of features that you use might be different depending on the model you use because of the compute that it's going to take. Right. Like a k-nearest neighbor, it says, you might have forget of which KNN or which one's heavy on compute, but it's going to be a lot different depending on your model. And that modeling of the data is also another aspect. It's not just pure math and what's going to work. It's what is the business impact of it. And that's part of the interpretation of results. And so, that the only way that works is if you tie it back to that original business case that you're going after as well.
So let me ask a question about the model in general. I think, as we talk about these steps, so the, obtain, scrub, explore, model, interpret, I think it would be easy for somebody to look at this and say, okay, this is what I have to do. First, I obtain the data, I scrub the data, I explore the data, model it, I interpret it. Now it's ready for production. I get the feeling based on what you're saying that that's really not the case, that this is actually a highly iterative process. And at any step, you may bounce back to the beginning and say, well, I actually don't have enough data. I don't have a broad enough data set or something like that. And you bounce back to obtain again and you cycle through that. Is that the case? Or is this kind of just a linear end-to-end thing and what you do it once and you're done?
So obviously it's very iterative. But there are some aspects of waterfall to it too. And that's what's really interesting. Obviously, it's almost like a safe agile, right? If I were to do a cop-out term there. But you iterate, but it's really important, especially with data science, is trying to understand as best you can, and that might get blown up later in the process, but how are you going to implement this at scale, one, and start thinking about that from the very beginning. And obviously that's going to change as you iterate through it, but that always has to be in the back of your mind. And then two, what is the real business case that we're solving, and how are we tracking it? Like, and that should try to be set in, or not set in stone, but that should try to be put out as quickly as possible, because it's the old saying, you never hire a data scientist to go find or go fix problems that you don't know about. It's like, I think that might have been from you, but you know, it can be really a fool's errand. But at the same time, if you do the things right and you have the process down, you're going to be coming out with tons of other discoveries as you're going through. So you're almost creating your new projects as you're figuring out what does this data look like? What is the problem? And maybe you're figuring out problems in your systems downstream, like, oh, actually, this is an issue here and this is an issue there. So really, it's very iterative, but at the same time, you can't forget about, the end goal of what you're doing, because otherwise you're going to pay a bunch of PhDs a lot of money. So
Right. And there is a place in my mind for what I'd call kind of purely exploratory stuff. But
yeah.
even then, it's constrained by a broader business question, right? So it may be, rather than saying, how do we decrease the risk of loss on loans due to default, right? It may be more of a broader question of what opportunities exist for us to reduce our costs and loss overall,
Yep.
right? In which case, you're still gearing towards something, but you're looking for, you know, anomalies, in a way. You're looking across the board to say, oh, hey, we're seeing something that jumps out from all the rest of the noise with regard to loss, with regard to cost, that maybe we should look at closer, right? But still, it always should be driven by a business question. All right, we've got a couple minutes left.
And again, the exploratory and statistics. That's
yes, exactly. Yeah, and you can get part of the way there with visualization, but having that statistics background is always very helpful. So the post model deployment pieces. Talk to me a little bit about the deployment and the feedback loops with regard to AWS tooling and what's available there to help kind of automate and ease the process for people.
Yeah, well, I mean, I think that there's a ton, right? There's things where you can deploy, and obviously the pipelines is going to be good, but then there's a lot of different ways to deploy the inference as well. So you can deploy, for example, you could deploy inference in other systems and run it on them. You could also run your models and have it be training at the edge, or things like IoT, to where you're not just collecting data from those sensors, you're actually pushing the model out to that little small computer out there, and it's running the inference at the edge. So that's another interesting way to do it. You can also do serverless inference, then you don't have to worry about managing the inference on the or the provisioning on the inference side. You can do multi-model deployments. You can do single point. There's a lot of multi-container endpoints that you can do, that then you can tie it in to your microservices and have that scale on demand. You can also do batch transformations, and all of these things can be done in numerous places. So you could be training, you could do stuff in Glue, you can do stuff in Redshift, you can do stuff just within the containers. There's a lot of different options depending on how you set up your pipeline, but having it all in AWS and being able to tie all those credentials together. And also another big update too, Michael, a couple of weeks ago, was that the S3, S3 endpoints or S3 security now supports SageMaker and up to 10,000, I think, which that really improves the ability to deploy models as well. So.
Absolutely. Any other? We're at 10:45 here. Any other final closing comments or pearls of wisdom you want to share before we wrap up for the day?
Um, there's no. They used to say this in advertising school. So there's no thing worth doing if it can't be tracked. So that's if I were to end on the feedback loop back into it, I would say that that's probably it. Is that we need to figure out better ways. Um, to be able to track and improve models. And I think that if we can get everyone on the same page, there's a lot of other human aspects that come into it. I think especially about one place, and that's health records and images and being able to analyze data and tie images back to actual labs, back to actual results. And if that was all figured out, you and I, Michael, we'd be living on our spaceship, traveling around the universe, I guess, for talking about this.
Yeah. And I think that, that ties back, even I go back to the days when I used to do some process reengineering work. And, what I always used to tell people, they're like, we want to improve our processes. I'm like, well, okay, are you measuring your processes? Well, no. Well, that's the first thing you do, because you cannot reliably improve a process that you are not measuring, because how will you know whether or not you've made an improvement? You need a metric that you can measure, that you can look at it and say, aha, I've actually positively impacted that metric.
Yeah, and the even bigger problem is figuring out what that metric is, and I think that's also a missing piece too.
Sometimes that's the hardest problem, is what's the right metric to measure.
Yeah, absolutely.
All right. Well, it's a little bit past now, so let's wrap this up. I want to thank everybody who's joined us today. We hope you have learned something. And if you've liked what you heard, please subscribe to our channels. As always, we are on LinkedIn Live and on YouTube. And also, we are available via podcast. We will take the audio from this and make it available. And the podcast is available on most major podcast platforms. So join us next week, and we will have another topic relating to data science on AWS. Thank you all very much, and see you again soon.
Thanks all.